Hi everybody, I'm Sam, I'm the TA for this term for ML, and we're going to go over Python installation and dependency management. So what we're going to do in this video is that we're going to go over what is Python, how do I install it, and some of the very basics of how to actually use Python. We'll focus on the language itself in the next video. In this video, we're going to restrict ourselves to just doing dependency management. So let's get started. What is Python? Python is an interpreted language. It's popular with mathematicians, scientists, data scientists, people like that. Machine learning grows out of data science mostly. The research community for it is very, very heavily math-oriented. So in some sense, we're using it because it's popular with the community. But more generally, it's popular for pretty good reasons that you'll start to see why. So let's also go over what it means for it to be interpreted. In a compiled language, you invoke a compiler like GCC or G++ or JavaC, and it gives you a binary, some sort of compiled representation of the program. Maybe this is bytecode in Java or C#, or maybe this is actual machine code in the case of, say, Rust or C++. An interpreted language, you invoke an interpreter on a file, and the file is then executed by the interpreter step by step. And this is really nice because it gives you this it gives you a lot of flexibility. If I'm running on a Mac and you're running on a Windows machine, you can just send me a file and I can run it on Python without really having to do anything. I don't have to cross-compile it. I don't have to hope that all my compiler particulars are correct. I still have to do dependency management, but we'll get there. Another reason it's popular is because it has really easy to read syntax, and in the next video when we go over how to actually use the language, you will start to see what I mean by that. It's weak and dynamically typed, so weak typing means that you can move data between different kinds of types relatively easily. It's not particularly hard to do that. And dynamic typing means that the types of variables can change over the course of the program. These are, in some sense, downsides. They make it harder to check what programs are going to do, and there are actually ways that you can use other software to check your Python programs for types. But in a lot of senses, it's also really nice, because it lets us get away with a lot of bad code that otherwise we would not be able to get away with, and that normally sounds like a really bad promise to make, but you're going to write a lot of bad code in ML. Writing bad code is second nature, because writing bad code is better than not writing code. And when we're just trying to explore a lot of concepts, when we're trying to build a lot of algorithms really quickly, that's really nice to have. It's really nice to just be able to write code that maybe isn't completely... It wouldn't pass Haskell's type checker, but it's good enough. The really big reason people use Python, though, is because it has very, very good libraries for scientific computation. And scientific computation here means vectorized computation. So it means computation where you're going to do the same thing repeatedly to a big data structure of very, very similar things. We'll see what that means a bit more when we get into NumPy and Torch, but what it means for now is that we get a lot of computation for free that normally we would have to use some very frustrating interfaces for. It's also commonly installed on systems, so you might already have it installed. So let's actually go over getting it installed if you need to. So if you're on a Mac, we'll deal with Mac, then we'll do Linux, and then we'll do Windows if you're skipping around in here. It might already be installed. So you can check by opening a terminal. You do this with command space and you search terminal. And then you issue the command python ---- version. Now this will probably not start with a 3. It'll probably start with 2. This is because Python had a really bad version schism some number of years ago, and as a solution to that, Python still points to Python version 2. So if it doesn't start with 3, which probably won't, you can do python 3 ---- version. If that works, you're still good. But whenever I say Python, you'll need to invoke Python 3. If not, you can go to python.org, downloads, macOS. Any version greater than 3.10 will work. I think 3.11 is the current most new version. So with Linux, the instructions are pretty much the same. If we're skipping around, I'll go over it. You can check by opening a terminal and issuing python -- version. That will probably not start with a 3, it will probably start with a 2. If it does start with a 2, type python 3 -- version. If that works, which is to say it gives you output, and the output starts with a 3 and says something like 3.10, you're good, but you will need to replace invoking Python with invoking Python 3. If not, it depends on your distro. If you're Debian derived, something like Ubuntu, you can say sudo apt install python 3-y. If you know how to use Nix, the package is nix packages.311, so you can say invoke a Nix shell like this. Others, you're going to have to see your manual. So if you're on Arch Linux, or if you're on Gentoo or some other distribution that people don't use all the time, you should go and consult your specific manual. So Windows is the odd one out here, because Windows doesn't come with Python, usually. So you're going to want to download it. You're going to want to go to python.org/download/Windows. Then you're going to want to download pip, the Python package manager, by using getpip.py. So you're going to want to go to that URL, bootstrap.pypa, and then follow any instructions there. But the way that you do it is pretty much that you run python 3 getpip.py. You may have to give it admin permissions, but I don't think so, though. So, virtual environments. Python projects have a lot of dependencies. Like I said, there are really, really good interfaces to really, really powerful libraries in Python, but they might conflict with one another. So one project may need a lower version of some library than another one. The solution to this is that you manage your dependencies per project rather than per computer, or per user or something. So the advantage of this is that you no longer get version conflicts, and if you need to freshly download everything, that's really easy. You can just delete the entire environment and rebuild it. Downsides is that now you have to install every package that you need multiple times if you have multiple projects that use that package, so you may need to clean these out occasionally, but that's probably a year out at least. From now on, I'm going to assume that you're using Linux, because the school servers, which will work for all of this, use Linux, and macOS looks pretty much the same, and I think Windows also really looks quite a lot the same as well. So you're going to want to make a directory called ML course Python or something similar, and then you're going to want to cd into that directory. It doesn't technically matter what this directory is called, just something you're going to remember. Then you're going to want to say python-n or -m venv env. This will create a virtual env called env in this directory. Then you're going to want to activate it, and you activate it by saying source env bin activate. You can also say dot instead of source. This will load things into your path. It will change how your shell works in a reversible way, and you should now see env in parentheses appear to the left of your shell prompt. You can say which Python to verify. Python should be installed locally rather than globally, so it shouldn't point to, say, usr bin. It should point to your directory env bin python, or something along those lines. Now, the dependencies that we're going to need for next time include numpy, Jupyter, and matplotlib. So you're going to want to install them by saying pip install numpy, Jupyter, matplotlib. This will locally install them. What they are: numpy is an ND array library, so this means multi-dimensional array library, so you can create, say, large three-dimensional arrays or n-dimensional arrays, and then manipulate them very easily using purely Pythonic ways of doing this. Jupyter is a really nice user interface called Notebooks. It gives you the ability to, say, like, render images without actually saving them or opening them, just like inline. Very, very nice. It's all a web interface. And finally, matplotlib, which is a graphing library. This should take a few minutes, so don't worry too much about that. All right, next time we're going to go over some of the basics of usage at the REPL, as well as how to use some of the basic Jupyter library functions, as well as some really basic stuff with NumPy. All right. Thank you, and I will see you in the next one.